do that worksheet here also. Okay. So I have to distribute the printout to others. Give me a moment. This is worksheet 1. Worksheet 1. No, yeah, worksheet 1. Okay. This is worksheet 2. Worksheet 2. And worksheet 3. We will be doing every question from this. We have 2 hours. We have 2 hours in this session, so we will be doing every question from this worksheet. I hope we can do that. Okay. Yeah. So you have all the worksheets with you. We have done every worksheet except worksheet 4 as the home assignments. So you have already seen these worksheets and you may have done these worksheets as home assignments. If you haven't, no problem. We will be doing that here. If there is any doubts regarding any questions of the worksheets, no problem. We will be doing that here. Okay. So let's take worksheet number 4. We are going to do worksheet number 4 as the first one. Take worksheet number 4. For the students online, I can show you the worksheet here. Worksheet number 4. Worksheet number 4, I can show you here. Worksheet number 4. Take worksheet number 4 and read the first question. Everyone. Take worksheet number 4, read the first question. Read the first question. Worksheet number 4, read the first question. Okay, what is the first question? Yes. I have selected the questions which may be somewhat confusing for you. I haven't selected the very simple questions. I haven't selected simple questions, only the questions that can be a little bit confusing. Okay. Try to find the answer, please. Hi, Ashwin. Hello, sir. Where are you?
Sir, we were correctly.
How many of you have come? 1, 3, 4, 5, 6, 7. 7 more. Okay. We are going to discuss the worksheet questions today. Worksheet. Your chapter has started today.
Not today, yesterday. Yesterday.
It was yesterday. No problem. No problem. After this, we can do that. I will do that today. Hi, Shiva. I'm happy to see you here. This is 4, 3. What? We didn't get the worksheets. Print out of the worksheets 1, 2, 3, 4, 5, 6, 7. Okay, 7 more. So we need 7 more. I counted it. Okay, here. Look at the first question. Hey guys, look at the first question, please. Look at the first question. Hey, look at the first question. This is worksheet number 4. We haven't done worksheet number 4. We haven't done worksheet number 4 before. So we are going to do worksheet number 4. Look at the first question. The apparent flattening of the sun's disk. What is this sun's disk? Sun has a disk. Does sun have this disk? No, this is just the shape of the sun. That is the disk of sun. Okay? So sun's disk at sunrise and sunset is due to. Why we are seeing sun as a large disk at the sunrise and sunset? That is the question. Due to what? Is it dispersion or scattering, atmospheric refraction, or Tyndall effect? Yes, Tyndall effect is not the answer. What is Tyndall effect? When light hit on tiny particles, it deviates and the path of light is visible. What is Tyndall effect? When light hit on microscopic particles, it deviates and the path of the light is visible, right? Okay. Here. So what is the answer? What is the answer here? Atmospheric refraction of light due to the refraction. It is due to the refraction, atmospheric refraction. Okay? Due to the refraction. Got it? Tyndall effect is not the one. What is dispersion? It's the splitting of colors. So it's not the answer. The colors is not splitting. The sun is seen as a disk. Why is that? That is the question. So splitting of colors is not the answer. Scattering of light. No, it's not. Scattering of light. Why? With what you can connect the scattering of light? With what effects you can connect the scattering of light? With what effects? Blue color of the sky, rainbow formation, reddish color of sun during sunrise and sunset. They are the causes. They are the effects of the scattering, not this. Why this is happening? Atmospheric refraction, just the refraction. That's why we are seeing a large disk as the shape of the sun. Okay, then look at the second question with the help of a diagram. This is an MCQ, right?
Yeah.
It's an MCQ. With the help of a diagram, explain Isaac Newton's experiment that led to the idea that the sunlight is made up of 7 colors. What is this? Help of a diagram, explain the experiment. Help of a diagram, explain the experiment. How you can do that? Explain the experiment with the help of a diagram. What are we doing? Worksheet for question number 2. Okay. What was the experiment done by Isaac Newton? What was the experiment done by Isaac Newton? There was 2 prisms. There was 2 prisms. The first prism is like this. This is the first prism. And he placed another prism, a second prism, close to the first one and upside down. Close to the first one and upside down. Close to the first one and upside down. Upside down. What is this? What is this? No. This line represents the base of the prism. The base of the prism. Upside down means this is now the base of the prism. Right? Okay. So what happens when a white light hitting on this surface? The surface is inclined, right? The surface is inclined. So there will be refraction. There will be refraction and dispersion also. There will be refraction and dispersion also. Okay? Due to the refraction and dispersion, colors are split. Colors are split. I'm not drawing all the colors. I'm just drawing the red color. I'll be just drawing the red color. Red color is split and also the violet one. Then what happens to these colors? They are getting out of the prism. They are getting out of the prism. Who has the least deviation? Red has the least deviation. So red will have the least deviation from the original path. This is the original path. Red has the least deviation. Who has the most deviation? Yes, violet has the most deviation. So it is coming out of the prism and it is entering the second prism. What happens now? Now again refraction happens. Again refraction happens. Right? Light will get refracted again. Light will get refracted again. So this is also refraction. Light will get refracted again, but in reverse manner. In reverse manner, then that is called the recombination. So here dispersion happens. Dispersion happens. Here what? Recombination happens. Recombination. Here recombination happens. Then at last, what happens to the sunlight? What happens to these colors? These colors are combining to form white light and it is getting out of the second prism. This is the first prism, this is the second prism. When it is getting out, it will be white light. It will be white light. When it is getting out, it will be white light. Got it? It will be white light when it is getting out. So this is the recombination. This was the experiment done by Hecw. And this is important. I have seen this question many times. I have seen this question many times in previous questions list. So this is very important. This experiment is very important. Okay? Recombination can be asked directly like this or with a diagram. Or with a diagram can be asked with a diagram. Or sometimes it will be in an MCQ. So the question could be asked any times, any kinds. So this is the crude idea of that. This is the final idea of that recombination. Recombination. This was an experiment done by Isaac Newton. Got it? Experiment done by Isaac. From this experiment, what did he understand? What did he understand from this experiment? Yes, the white light is actually composed of 7 component colors. He got that idea. He got that idea from this experiment. Did you understand this?
Yes.
Abdullah, Zoya, did you get it? Recombination. This is the recombination of colors. Got it?
Yes.
So just look at the question again. What is the question? With the help of a diagram, we have done the diagram. Okay. Explain Isaac Newton's experiment. You have to explain it. You have to explain it. Can you write it? You have to explain it. Can you write it?
Yes.
Yeah. Just explain that experiment. Just explain the arrangement. That is the explanation of the experiment. Just explain the arrangement. The first prism is there. The first prism is there. Then first prism disperse light and the colors are split. Yeah, you have to draw this because in the question they are saying, they are asking for you to draw the figure, draw the diagram. So this is it. Okay, this is it. This is it. This is very important. Very important. Okay. Is there anything to add about this one? Done by Isaac Newton, and this experiment gave him the idea that white light is composed of 7 component colors. What are they called? 7 component colors or constituent colors. Sometimes in the question paper it may be like this: constituent colors or component colors. Got it? Everyone? Alvin, is it okay?
Yes.
Abdullah, did you understand this one? Zoya? So this is it. The first prism, dispersion happens. In the second prism, recombination happens. Okay now? Okay. I hope you can draw that. Everyone. Can I move to the next question?
Yes.
Just draw it. You have already that in your notebooks. You are just revising it. That's all. Okay? Now, let me ask you a question related to this. Just a question, just a question. You don't have to write it. I'll just ask it, you can answer me. In which of in these colors, which have greater wavelength? Red has greater wavelength. Which has greater, shorter wavelength? Violet has the shorter wavelength, right? Whose angle of refraction will be greater when the light is coming out of first prism?
Red or violet?
Red or violet? That is the question. Red or violet? Whose angle of refraction will be greater? Red or violet? Can anybody tell me? Can anybody help me here? Alvina, Adulya, Lionel, Rania, Saida. Which will have a greater angle of refraction? Red or violet? Answer me, please. Respond to me.
What's the question again?
Which will have a greater angle of refraction?
So violet.
Yeah, violet. That's the answer. Red has the least deviation, right?
Yes.
Red has the least deviation. Violet has the most deviation. Violet is deviating from the original path in a larger amount, in a greater amount. So violet will have a greater angle of refraction. Just a question. You don't have to write it. Okay? Understood it?
Yes.
Can we move to the next one?
Yes.
Just look at the next question then. Look at the next question 3. The third question. The third question. Look at the third question. Third question. It has A and B. Third question A. Here. Why do the component colors of incident white light split into a spectrum while passing through a glass prism? Explain. Why? Why the white light is splitting into component colors? That is the question. Why the white light is splitting into component colors? What is spectrum? What is the meaning of spectrum? What is spectrum?
Combination of
Band of colors or band of color components. Band of color components of white light. Band of color components of white light. When you are arranging the colors, the 7 component colors of the white light in a band, you can call it spectrum. When you take red, orange, yellow, and you arrange them as one after the other, you can call it as spectrum. So that is spectrum. Okay? That is spectrum of white light. It has 7 component colors. Why? When the white light is entering and passing through a prism, why the white light split and the 7 component colors are out? That is the question. Why it is splitting? Why component colors are splitting? Why dispersion happens? That is the question. Why dispersion happens is the question. Yeah. You can answer that with the idea of wavelength or the speed. You can answer the idea with the wavelength or speed of colors. Why the colors split? Why the white light is splitting into 7 component colors?
Different wavelength.
Yes. That's it. Each color has different wavelengths. Yeah. So each color will have different speed in prism. Each color will have different speed in prism. So each color is refracted at different angles. Got it?
Yes.
What is the first one? Each color has different wavelengths. Each color has different wavelengths. Each color has different speeds in the prism. When the light is traveling from one medium to another, speed changes. Okay? So they are refracted at different angles. They are refracted at different angles. Different angles. We have already written this answer in your notebook.
Yes.
Cause of dispersion. Why dispersion happens? We have already written that in your notebook. So tell me, what is the cause of dispersion? Tell me. Each color has different wavelength. Each color has different speed. So they are refracted at different angles. They are refracted at different angles. Okay, red will be coming out of one angle and the orange is coming out of another angle. That's why red is red and orange is orange. That's why we can separately see red and orange. If red and orange are coming at the same angle, what happens? If red and orange are coming at the same angle, what happens? They will mix. That's it. They will mix. If with your 7 colors are refracted at the same angle, what happens? White light. If 7 colors are refracted at different, same angles, then you will get white light as the output. You will get white light as the output of the prism. It does not happen. Why? It does not happen. Why?
Because it has different angles.
Yeah. Because the light is entering through the lateral surface, lateral rectangular surface of the prism. It is at an angle now. It is at an angle now. If it is entering at an angle, what happens? Refraction happens. And how will be the refraction? Each color will be refracted at different angles. You get it? Each color will be refracted at a different angle. Do you need this as the form of an answer? Huh? Do you need this for like an answer? Anyway, I'll tell it anyway. Okay. Just check it like this. Different colors have different colors has different wavelengths. Different colors have different wavelengths. Okay, their speed in prism will be different. 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 So they are refracted at different angles. So they are refracted at different angles. Did you write inside? So they are refracted at different angles. You get it? Alvina, Adulya, Lionel, Rania, Zaida. Can I move to the next question?
Yeah.
Everyone, Abdullah, is that okay? Okay. Then the next question. Next question, question B. Draw a labeled ray diagram to show the formation of a rainbow. So very simple, right? Formation of a rainbow. Question B, formation of a rainbow. This is question A and question B. How was the figure? How was the figure? Why rainbow? You can observe rainbow. Why you can observe rainbow? What is the reason? If the question is for a single mark, for 1 mark, what is the reason of rainbow? What is your answer? Just 1 mark, just 1 word. Is it refraction, reflection, dispersion, scattering? Why? Refraction is happening there. Dispersion also happens there. Total internal reflection also happens there. If there is an option, all of them. But you will select as the correct answer. Is that right? Scattering is the reason. Scattering is the reason. No, scattering is not a reason. Scattering will not be a reason. If there is scattering, you cannot select all of them. If all of the above and except scattering is there, then that will be the answer. Refraction happens there. dispersion happens, internal reflection happens, then again refraction happens. So how many times refraction happens when the during the rainbow formation? How many times? How many times? Two times. Two times refraction happens in a raindrop. How many times total internal reflection happens? Only once. How many times dispersion happens? Is it? Yes, once. Dispersion happens only once inside the raindrop. Okay. So what is this? This is a raindrop. Okay. A light ray is entering the raindrop. What will happen to this light ray? What is the first step? It will get dispersed. Dispersion will, sorry, first one is refraction. First one is refraction. First step is refraction. And it will get dispersed. Dispersed. That means component colors are split. Component colors are split. Hey, component colors are split. Then what happens?
Reflection.
So we have a refraction and the second one, dispersion, and the third one, internal reflection. It is reflected back to the same medium. It is reflected back to the same medium. That is reflection. Reflection. So this is reflection. Reflection. And violet also is reflected. Not only red and violet, all the colors are in between. All the 5 colors are in between red and violet. Okay. Then what is the final step of formation of the rainbow? Fourth step of formation of rainbow. The last refraction. The last refraction. It is again refracted. It is again refracted. It is again refracted. Can you see this? It is again refracted. See this? Can you explain this? How is a rainbow happening? When white light enters a raindrop, it gets refracted and dispersion also happens. 7 component colors are split inside the raindrop. Then they are totally reflected, again refracted, and comes out as different colors. Each color will be at different angles. That's why we can see rainbow. Okay, that's why we can see rainbow. Just look here. The angle of red is greater. Angle of red is greater. Angle of violet is lesser. So we will see red on top, violet on bottom. Got it? Angle of red is greater and the angle of violet is lesser. So we will be seeing, we will be observing red on top, violet on bottom. Okay. Can you explain that? You have the notes. Say direct question. You don't have to write it now. Is it okay? Can I move to the next question?
Yes.
Have you drawn it?
Yes.
You have that in the notebook. If you want, you can. Okay. Just repeating everything we have studied is the best correct method to study something. Repetition. Repetition is the method of studying something. Yeah, consistency, repetition. Hey, then the next question. The next question. Okay. Look at the fourth question, guys. The fourth question. Fourth question. Fourth question. Which one of the following is the correct reason for twinkling of stars? Don't answer this. Don't answer this. Don't answer this. Which one of the following is the correct reason for twinkling of stars? Ishana, can you answer this one? Only Ishana. Ishana, can you help me with this one? Which of the following is the correct reason for twinkling of stars? Yes. Yes. That's the answer, right?
Yes.
Atmospheric reflection. No, not reflection. Not reflection. And the scattering of starlight. No scattering during night time. Dispersion of there is no colors. So what is it? Atmospheric refraction of starlight. Got it? Atmospheric refraction of starlight. A simple question. 5. What is 5? with the help of a labeled ray diagram. What is a ray diagram? Ray diagram representing light as rays. Diagram showing light as rays. Diagram drawn with the light as rays. Is the light actually a ray? No. Light is a wave. It's a transverse wave. It's an electromagnetic wave actually. It's an electromagnetic wave. Okay? Okay? Okay, but we can represent the light as ray. What is ray? Path of the light. If we draw a line for the path of the light, that is called a ray. That is called a ray. So if we represent the light as ray, then we are drawing something that is called a ray diagram. Okay. So with the help of labeled ray diagram, show the path followed by a narrow beam of monochromatic light when it passes through a glass prism. Which diagram you will be drawing?
This question has like one.
Which diagram? Is this the diagram you are going to draw? Hey, hey. Is this the diagram you are going to show in your transition? This is not. Why? Why you are not using this diagram?
Because they will see the way that these things.
No. Yeah. I will show the question once more. The answer to my question lies in the question itself. With the help of labeled ray diagram, path followed by a narrow beam of monochromatic light when it passes through a glass prism. You have two diagrams for the refraction of prism, right? The first diagram, only one light, only one path, one ray of light is coming, and there is a second one where the light is splitting and component colors are out. You have two diagrams. Okay, you have two diagrams. Which diagram you will choose according to the question? The first one. Why? No. Both of them are glass prisms. First and second are glass prisms. My question is this. I will make it more simple. Why dispersion is not happening? In this case, when you are drawing this case, there will not be dispersion. Why? Can you help me with this? Anybody answer?
The question.
Yeah, question is this is the question. Dini, can you help me with this one? Why dispersion is not happening? There will only be refraction. Why only refraction? No dispersion. No, both of them are prism. No. For recombination, you have two prisms. No. Beam, not that. What is the answer? This is the answer. Be silent. This is the answer. We are using a monochromatic light. What is a monochromatic light? Did you say it? Monochromatic? Yeah. This is the term. Monochromatic. What is monochromatic? Mono.
Sir, one.
Yeah. Mono. Mono means one. Chromatic color. That means only one color. What is the meaning of only one color? Yeah, no splitting. What is actually one color? No. White light is not monochromatic. White light has 7 colors. Okay? Okay? There will only be one wavelength. Only one wavelength. Huh? No, it could be anything. It could be any color. It could be any color. But the wavelength will be only one. If there is only one wavelength, is a monochromatic light, red color. A laser light. A laser is monochromatic. It only have one wavelength, one color. Laser could be red. Laser could be green. Laser could not be. It is also the. But mixing of colors. When the colors are mixed, you cannot call it monochromatic. Okay, monochromatic means only one wavelength is served. If there is only one wavelength, no dispersion. Got it? You get the idea? If there is only one wavelength, no dispersion. So the figure will be first figure. The figure will be first figure. This figure. Huh? Should I draw the figure again? I'll draw it again. What is question number 5, right? Question number 5, guys. Hey, question number 5. This is our prism. Huh? This is the prism, and light is entering the prism in this direction, and the light is hitting the prism at this point. Then at the point of incidence, you can draw a line. What is this line? What is this line? Yeah, the line is normal. The line is normal. And what is this extension? Original path of incident ray. The original path of incident ray. Original path of incident ray. Got it? Original path. What happens to this monochromatic light? Refraction happens. What happens to this monochromatic light? Refraction. And it is from rarer to denser. So towards the north. Towards the north. Is like this. Got it?
Yeah.
That is the second line. And what happens at the point of incidence after this? Again another normal. So this is N2. What happens to the light after this? Shut up. What happens to the light after this? This. What happens to the light after this? It gets refracted. No. This is now denser to rarer. So what happens? Away from normal. Denser to rarer. Away from normal. What is it? Denser to rarer. Away from normal. Okay. So it is away from normal. Now my question is, what is this light ray called? Yeah. This light ray is called the incident ray. Incident ray. Are you writing it?
Yeah.
Incident ray. What is this? Emergent ray. Emergent ray. This is emergent ray. Okay? These are normals. This is normal. And what is this angle? Michael, what is this angle? Yes, good. Angle of incident. Angle of incident. And what is this angle? This is actually the angle of refraction. This is the refracted angle. This is a light ray that has refraction. So refracted ray and normal has an angle of refraction. This is the angle of refraction. That's angle of refraction. And this angle will be equal to this one. It will be equal to this one. You can call it as R. But at this point, it can be called the angle of incidence again. Why? It is going to incident on a point. It is going to incident on a point, so can be called angle of incidence again. You don't have to call it, you don't have to show it. Okay. What is this called? This ray is emergent ray. Emergent ray. And what is this angle? That is angle of emergence. Angle of emergence. Yeah. You have to only understand about two angles: angle of incidence and angle of emergence. Sorry, angle of emergence. This is angle of emergence. Angle of emergence. Now another question: is this incident angle and emergent? Incident ray and emergent ray are parallel to each other? No, they are not parallel to each other. So there will be an angle between them. The incident ray and the emergent ray are not parallel to each other, so there will be an angle between them. What is the angle? Angle of deviation. What do we call it? D. Angle of deviation. Did you get it? Angle of deviation. So what is the angle of deviation? Abdullah, what is the angle of deviation from the figure? Angle of deviation. Did you understand this one? Zoya. You two are the new students here. So angle of deviation, did you understand that?
Yes.
Yes, what is angle of deviation? Yeah, original path of the. What is angle of incidence? Abdullah, here. This is the original path of the incident ray. This is the incident ray. This is the path that incident ray is supposed to go. It will not go there. It will not follow that path. It will get refracted. It will get refracted 2 times. Right? It will get refracted 2 times. And this is emergent ray. When the light ray is coming out, you can call it emergent ray. Emergent ray is not parallel to incident ray. So there will be an angle between them. That angle is called the angle of deviation. So what is angle of deviation? Angle between. Say that with me. Angle between original path of the incident ray and the emergent ray. Original path of the incident ray and the emergent ray. That's it. Okay. So this is our question. Sorry. Refracted ray. Yeah. What is the refracted ray? This is the refracted ray. This is the refracted ray. Got it? This is the refracted ray. Don't make sound. There is people online. Don't make sound. Okay, be silent, everyone. The next one. Read the next one. We discussed the question A. Okay. Now B. What would happen if this beam is replaced by a narrow beam of white light? Actually, give me an answer. Give me an answer. What would happen if this beam is replaced by a narrow beam of white light? In this question, now the beam is replaced with a narrow beam of white light. What happens? That's it. Dispersion happens. Dispersion happens. Then can you draw and label it? Yeah, we can do that. I'm not asking for you to draw that. You can do that, right?
Yes.
Dispersion, draw the dispersion. So what is this? This is A and B. What is the answer of B? Yeah, dispersion happens. What is the answer of B? What is it? Dispersion happens. Dispersion happens. Did you get it? If it is a monochromatic light, only refraction. If it is a white beam of light, dispersion happens. Get it? Huh? Yeah. That's the answer. Answer to question B. Dispersion happens. Did you write it? Dispersion happens. Can you draw it? Can you? You can? That's all. Abdullah, dispersion. Have we discussed the dispersion? Abdullah and Zoya, did we discuss dispersion? Okay, I can show you that. Be silent, please. And look. Hey, everyone, please look here. This is white light. This is white light. And when white light is incident on a prism, what happens? This is coming obliquely. This is hitting on the prism obliquely. And this is white light. So dispersion happens. What is dispersion? Splitting of white light. Splitting of white light. So this is the splitting of white light. That's red. The second one will be orange. And the third one will be yellow. And the fourth one will be green. And what is the fifth one? The fifth one is blue. What is the fifth one? Indigo. And what is the last one? What is the last one? Violet. This is what happens at a prism when a white beam of light is entering the prism. When a white beam of light is entering the prism, this is what happens. You have that. You already have that, and also I have given you the PDF of this one. PDF of the handwritten note is also. Yes, this is dispersion. No, there is not only dispersion, but also refraction happens. There will also be refraction. Who has the greatest deviation in it? Violet has the greatest deviation in it. Who has the least deviation in it? Red has the least deviation in it. Why? It has, yeah, it has the greatest wavelength. It has the greatest wavelength. When wavelength increases, deviation decreases. If wavelength decreases, deviation increases. Got it? Trini, is that okay? Abdullah, is it okay now? This is dispersion by diffusion. Yes. Yeah. Which has greater deviation among yellow and blue? If there is a question, and the question is like this, which has the greater wavelength, yellow or blue? Yellow. Greater wavelength. The question, which has the greater wavelength? Yellow has the greater wavelength, so yellow has the least deviation. Blue has lower wavelength, so blue has greater deviation, high deviation. Got it? Can I move to the next question? Okay, so what is the takeaway point? If it is a monochromatic light, what is this light?
Monochromatic light.
Monochromatic. If the light is monochromatic, then refraction only. If the light is white beam of light, then if it is a white beam of light, then only dispersion. Dispersion and refraction will be happening. Get it? Okay. Alvina, Adulya, Lionel, Rania, Saida, did you guys understood this? Can I move to the next question?
Yes. Yes, move on.
Okay, thank you. Look at the next question, question number 6. Question number 6. What is it? Which of the following statement is not true for scattering of light? For scattering of light, which is not true. What is scattering? Don't look at the question. What is scattering? When light hit on microscopic particles, its path deviates. Its path changes. Its path deviates. Then the particles are light up. The particles gets lighted up. So we can see the path of light. So we can see the path of light. You get it? That's called a Tyndall effect. We can see the path of light is called a Tyndall effect. Just the deviation is called a scattering. Got it? Deviation is called a scattering. So look at the question. And what about the points? What are the other points about the scattering? When wavelength increases, what about scattering? When wavelength increases, scattering is actually depending on the size of the particles and wavelength. If wavelength increases, what is the if wavelength is large, then scattering will be very less. Scattering will be very less. If wavelength is large, scattering will be less. If wavelength is low, scattering will. This is low wavelength. This is low wavelength. This is larger wavelength. Is it? So this is lower wavelength. Okay? Did you get it? Huh? Get it? This is larger wavelength and this is lower wavelength. Okay. If wavelength is low, what happens? Scattering will be more. Scattering will be more. Okay. Blue color of sky due to the scattering of light on microscopic tiny particles present in atmosphere. And this red light has 1.8 times greater wavelength than bluish lights. Blue. So blue will be scattered. When the scattered light reaches our eye, we can see the sky as blue. How we are seeing a color? How we are seeing a color? Which wavelength is entering our eye? Which wavelength is entering our eye? We will be seeing the object as that color. If red, the blue light is entering my eye, reflecting from this, the blue light is entering my eye, so I can see this object as blue. I thought you are asking me to go. Okay. Then now look at the question. Now look at the question. Hey, color of the scattered light. Color of the scattered light depends on the size of particles of the atmosphere. Isn't it? Is it true or false?
Yes.
Color of the scattered light depends on the size of particle of atmosphere. Yes. If the size of particles are small, then shorter wavelengths are scattered. That's why a clear sky scatters blue light more. Okay. If the size of particles are larger, then every colors are scattered in same amount. That's why white clouds can be seen as white. In clouds, what are the particles? In clouds, the particles are water droplets. In clouds, the particles are water droplets. Okay, so they are scattering every colors in the same amount. So every colors are scattered. If the every colors are scattered, that's white light. Okay, small particles scatter, shorter wavelength. Larger particles scatter every colors in the same amount. Yes. Huh? Not the scattering. You cannot say it like that. If the size of the particle is small, then shorter wavelengths are scattered.
So if wavelength is more, scattering is less. If wavelength is more, scattering is less.
Yeah, if the wavelength is high, scattering is less. Red has greater wavelength. Scattering is less for red. Okay. So what you will write about this point? First point is true, right? First point is true. And what you have to understand from this first point, shorter the wavelength or smaller the particle, shorter wavelengths will be scattered. Okay. Okay. Then red light is least scattered in the atmosphere. That's why we are seeing the sky as blue, because red light is least scattered in the atmosphere. Okay, then see, scattering of light takes place as various colors of white light travel with different speed in air. Is it true or false? Is it true or false? Let that point stay there. Look at the T, point T. The first part, the fine particles in the atmospheric air scatter blue light more strongly than red. True. So the scattered blue light enters our sky. That's why we are seeing sky as blue. Okay? So this is also true. Now look at C. Now look at C and tell me, is it true or false? It is false. It is false. Okay? It is false. What is the correct statement of that? Saran, what is the correct statement of C? C is a wrong statement. What is the correct statement of C? You don't have to keep on with it. Just read the point and you can convert that point into your point. Do different colors of white light has different speed in air?
Yes.
Yeah, they have different wavelengths. So different colors in air will have different speeds.
Yes.
Then this is right? Then this is true. No, this is not true. When speed of the light changes? When speed of light changes? When speed of light changes? That's it. If it is going from one medium to another, speed changes. Air is just one medium. Air is just one medium. There is no medium change, so there is no speed change. Every colors will have same speed in air. Got it? What will be that speed? What will be that speed? What will be that speed? It's not your speed. What will be that speed? That speed is nearly equal to 3 into 10 raised to 8 meter per second. Speed of light in vacuum is nearly equal to speed of light in air. So it is almost equal to 3 into 10 raised to 8 meter per second. Speed of light in air. That means red will have this speed, violet will have this speed, blue will have this speed. Every colors will have the same speed if it is traveling through air. If it is trying to pass through another medium, speed changes. Okay? Speed changes. Got it? That is the cause of refraction. That's the cause of refraction. Why there is no refraction if the light is traveling through air?
There's only one medium.
There is only one medium. There is only one medium. No medium change is there. So no refraction.
So what's the option?
This is false. This is false. So which of the following statement is not true? What is not true? C is not true. Get it? You can write it. C is not true. Did you understand why C is not true? Get it? Why C is not true? Abdullah, is it okay? Why? The Y part, you get it? The Y part, why it is not true? Okay. Now look at the next question. Yeah. You can take a break at 7:35 and take 10-minute break. 10-minute break, 45. Up to 7:45. Did they teach? Did they start electricity in school?
Yes, sir.
In yesterday. It was.
It was like all.
പക്ഷേ എനിക്ക് ഇത് കംപ്ലീറ്റ് ചെയ്യാനുണ്ട് ചില ക്വസ്റ്റ്യൻസ് എനിക്ക് കൺഫ്യൂസിംഗ് ആയിട്ട് വളരെ സിമ്പിൾ ക്വസ്റ്റ്യൻസ് ആണ് കഴിഞ്ഞ വർക്ക്ഷീറ്റിൽ കുറച്ച് ക്വസ്റ്റ്യൻസ്
Excuse me, sir.
You can take a 10-minute break, everyone. Online. Lionel, Alvin, Adulya, Rania, we will continue our session at 7:45. Yeah, Lionel.
I'm sure the question papers, we corrected it over the last class.
No, Lionel, I didn't do that. I couldn't
well-
take time to do that. I was a little bit engaged. I'll do that.
Okay, sir, no worries.
I'll inform you. Okay.
Yeah, okay, sir, no worries. Thank you.
Why is black?
Because why it is black?
Yeah.
Why it is black? Tell me. Why it is black?
Sir, absence like.
Okay, Lionel.
Yes, sir. Okay. Okay, sir.
You can take a break. We will continue at 7:45.